Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Get Snowed by Shadow Nevio, and here are the rules. It's chaos construction, and this is so I love chaos construction rule sets, so I would like to be able to show a very easy one is very uncommon. So I'm curious how this is going to work. We have in chaos construction, in every row and column, each digit from 1 through 6 occurs exactly once. In addition, there are 6 continuous regions in which each digit from 1 to 6 occurs exactly once. The shape of these regions have to be determined by the solver. And by continuous, basically that means to get from any cell in that in a region to any other cell in a region, you have to be able to go through edges all while staying within the region. So, for example, this is a valid region, right? To get from here to here, you can just go through edges and stay within the region all the while. This here would not be an example of a valid region because to try to get from this cell to any other cell in the region, you have to either go through a corner, which is not allowed, or go through an edge outside the region, right? You'd have to exit outside the region before you can get to that other cell. And similarly, this is also not a valid region because even though these two can get to each other by going through edges, they cannot get to the other cells in the region just by going through edges while staying within the region. So that's an example of how chaos construction works. We have XV dominoes, where cells separated by an X must sum to 10, and cells separated by a V must sum to 5. Not all X's and V's are necessarily given. There is no negative constraint, in other words. So, for example, if this were, say, a 3, this would have to be 2, right? I don't know why I have that. If this is 3, this would have to be 2, because these two digits must add up to 5. And these two digits must add up to 10. I'm not going to give an example because that would start solving the puzzle. Anyways, what else do we have? We have region sum lines, where region borders divide each blue line into segments with the same sum. And every region sum line is split by a region border at least once. There's no full sum line in the exact same region. So along the region sum line, say that we had a region border here, right? Then these two digits would have to add up to what these two digits must sum up to. So you could have something like, say, 1 and 5 and 2 and 4. And this would be valid as a region sum line because these two digits add up to 6 and these two add up to 6 also. And that's an example of how region sum lines work. And finally, we have snowflake Kropke dots, where digits in cells separated by a snowflake are consecutive. And snowflakes indicate region borders. So that means a snowflake is a region border also, and not all snowflakes are necessarily given. So for example, if this were, say, a 3 here, this would have to be 2 or 4. Because the snowflake indicates that the cells separated by the snowflake, first of all, are consecutive, and there's a region border where the snowflake is. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so what I like doing for chaos construction rules is putting a grid around the entire, putting a border around the entire grid. Because we know for typical chaos construction rules, and this is typical essentially, but it's just 1 to 6, you have to, the borders stop at the edge of the grid. We know the snowflakes are all borders, so we can draw those borders in. We know so what I like doing is like coloring in regions. We know this part is definitely part of a region because, and these two are separate regions because the snowflake indicates region borders. So this is definitely part of one region. This is definitely part of another region, and it cannot be the same as the green region. And it stopped here, so it has to go at least to here. This is the same for blue. It cannot be the same as this one. And the reason why it can't be the same as this green is these two are separate regions. So if we try to connect this, this is 1, 2, 3, 4, 5, 6, 7, 8 at minimum. But every region only has 6 digits, right? Because you can only contain the digits 1 through 6 once each. So that's why these are different regions here. What else do we have? Oh, this has to be a 4-6 pair. Because we know that you have only the digits 1 through 6 in this puzzle. And the only two that add up to 10 are 4 and 6. And this digit is consecutive with this digit. It can only be 3 or 5 here, then. The rest of this row is 1, 2, 3, and 5. This is definitely a border. And these are consecutive. So we know, one thing we know is this can't be divided into 3 separate regions, because if it were 3 separate regions, the problem is that it would basically have to, these 2 digits would have to be the same. And you can't have 2 digits that are the same in the same row or column. So these 2 must be the same region. If they were, say, blue, the problem is that we know these 2 are separate regions, so this would have to be a different region than all of these, but then this can't be continuous with the region that it's going to be a part of. And every cell in this grid must be part of a region, because it's 6 by 6, right? And there are 6 continuous regions, each containing the digits 1 through 6. So this has to be a separate region than blue. So this must be, we're going to make this orange. And this cell must be the same region as these 2, because it cannot be with blue, so this is orange there. Therefore, blue has to go out this way. This is a border then. This could be blue, we don't know. Orange has to go out one of these 2 ways. If it goes that way, okay, so if orange tried to go out this way, the problem is this is definitely a different region. But then the problem is this different region only has 4 other cells that could be part of its region when it needs 5 other cells, right? Because the orange would block here. This would be a different region, and then it would be stuck, right? It would only have 5 cells possible when it needs 6. So orange cannot go this way, therefore orange is guaranteed to go this way because it has to go out to get a full 6 cells. Now this could be part of orange, we don't know, but this must at least extend to that way because there is no other extension there possible. Okay, so say this wasn't orange. The problem is then this could not go orange there. So to fill out the rest of this orange region, it either has to go here or here. It cannot go here because then these 2 cells would not have a region, right? Because they'd be stuck here. And if we try, so it can either go here or it could go here. Well, if it goes here, the problem is this part would have to be part of a region, and these would also have to be part of a region, but they would have to be the same region because there's no other thing. And we know that there's a region border here, somewhere along this region sumline, because we are given that constraint. So it cannot be orange here, therefore it must be orange here. And this is a region border. We're going to make this pink. And again, this must be one full region because there is no other possible region this way. It can't get out any other way. So this is all one full region. And it could go up to here or here. This cannot be all green. And it cannot be all pink. So therefore, there must be a region here. We're going to make this yellow. Technically, you could have yellow go that way. But if that were the case, so if we try to have yellow not be part of this cell must exit out. And then the problem is this is not going to be able to form a full region. So we're trying to avoid having this be yellow. So to avoid having this yellow, this has to be a different region. It cannot be pink because of the snowflakes that surround it. So if we try to have it as red, it's too many cells, right? 1, 2, 3, 4, 5, 6, 7, 8. If we try to have it as blue, it's too many cells. 1, 2, 3, 4, 5, 6, 7, 8, and 9. If we try to have it as green, yellow has to go out somewhere. And it would be blocking the green from getting there. So this is not possible. And it would be too many cells. So this has to be yellow. So this is yellow and yellow. Yellow has to go out somewhere. This cell cannot be green. It cannot be red. That's too many cells. 1, 2, 3, 4, 5, 6, 7. Cannot be blue. Cannot be pink. So this also has to be yellow. Since these two are yellow, if we try to not have this as yellow, the problem is that it would not be part of our region because the yellow needs to connect, right? So this has to be yellow also. Okay. Now, what happens if this is yellow? If this were yellow, the problem is we have 3 unique digits, right? They're all in the same region, so they have to be unique, which would add up to another digit. Well, that is possible if this were 6. But the problem is 6 plus another digit can never add up to 5. So therefore, this can't be yellow. This must be green. Yellow has to be able to go out to form a region. So this must be yellow and yellow. And that's the whole yellow region. Pink has to go out to form a full region. So this is pink. So we have 6 cells in the pink region. And that's done there. The blue has to be able to go out. These are basically they cannot be orange or yellow or pink because those regions are filled because we have 6 of cells in those regions. This cell can't be red because of the snowflake between them, which means there's a region border between those two. And it cannot be green because that would be too far away. So the rest of this must be blue. This can only be, well, it could be green. We don't know, actually. This has to be green, though. Okay, so then since this is green, it must connect to the rest of the green. And it cannot connect this way because then this cell would not have a region, so it has to connect this way. Therefore, the rest of this is red. And we have all of our regions. Okay, so we know these 2 cells. So let's fill out the rest of the V's and what with snowflakes we have there. So these must add up to 5. Let's see. Whatever digit is, so this is normal irregular Sudoku. Whatever digit is here, obviously can't be in the green region because they are in the same. It can't be in column 1. And it has to be in the green region somewhere. So this digit has to be the same as this one. So this is, we're going to mark it as A. That's A. Where is it in the blue region? Can't be here. So A has to be one of these 2. In the yellow region, it's the same thing, right? Yet A cannot be here. Can't be here. It has to be in one of these 3 cells here. That means we cannot have an A anywhere in columns 3 and 4 because we have one already in the yellow region and one in the blue region. So the orange region, A has to be one of these three. Because it can't be here because of the A's in the row. Okay, is that helpful? I'm not sure. This cannot be A, because if this were A, this sum must equal this sum, and if this was A, you subtract out A from each side, these would have to be the same digit, which is not allowed. So A cannot be here. A cannot be any of these cells, cannot be here, so A in the pink region must be one of those three. Okay, so far not too helpful. This is consecutive with two other unique digits in the pink region. So this cannot be 1, which means this can't be 4. If this is 2, this would have to be 1 and 3. If this is 3, this would have to be 2 and 4. If this is 4, it would have to be 3 and 5. These two digits must sum up to what that digit is. So this can never be 5. So this has to be 1 through 4 at most also. This digit's consecutive with this. This digit's consecutive with this. So this is 1 through 5 also. So A can never be a 6. Actually, A can never be here. A can never be here. So where is A in the row 4? It has to be one of these two cells. So this can never be A here. These digits are consecutive. So this must be a 1 here. 1 plus another digit is its consecutive digit. If we try to have any other digit here, then these wouldn't be consecutive, right? Because this plus that, which is not 1, would equal that cell there, and therefore if it's not 1, they would not be consecutive, right? Because consecutive digits have a difference of 1. So this is 1. It could be A. We don't know. That eliminates 1 in the rest of the region. This can't be 2. So 2 has to be one of these two here. A is one of these. So this at least... This can't be 2 because it has 2 unique digits adding up to it. And that would mean that's a minimum of summing up to 3. So that means where is the 2 in row 4? It has to be here. So this is 2, which eliminates 2, 3 as a pair, which means this is a 1, 4 pair. So this cannot be A, because A cannot be 1 or 4 either, because A has to be this cell. So therefore, this must be A here. Since this is A, we know none of these two cells in the pink region can be A, so this has to be A over here. Which means this is not A here. Where is A in the yellow region? It has to be here, which eliminates A from being there, so this is A there. And it must be 3 or 5. So all the A's are the same digit. And it's 3 or 5. That means to add up to 3 or 5, this must be 2 or 4. Right? Because it's 1 plus another digit equals 3 or 5. But say A was 3, then this would be 3, this would be 3, and these two digits must add up to 3 also, because this is of the region sum line here. But this would guarantee this is 1 and 2, and this would have to be 2 to add up to 3 here. So A cannot be 3. A has to be 5. So A is 5, which forces this to be 3. This then becomes a 1, 2 pair to add up to the 3 here. So this is 1 and 2. This must be 1 and 4 adding up to 5. This 5 cannot be 1 and 4 adding up because of the 4 in the column. So this is a 2, 3 pair, which eliminates 2 and 3 in the rest of the region. This 5 eliminates 5 in the rest of the region. Therefore, to be consecutive with 1 or 4 here, this can't be 4 and it cannot be 5, so we have a 2-3 pair here. 5 is consecutive with 6, so this eliminates 6 here, so that's 4, which eliminates 4 here, so that's 6. The rest of the red region is 1 and 2. That leaves in column 2, the remaining digit is a 4. So this can no longer be 4 and 1, adding up to 5, it's 2 and 3. This 2-3 pair eliminates 2 and 3 in the rest of column 4, so this can't be 2. This is 1, which eliminates 1 here, so that's 2, which eliminates 2 here, so that's 1, which eliminates 1 here, so that's 2. Okay. These digits are consecutive. In the pink region, we only have 1 and 4 left because we have a 2-3 pair in the region, and 5 and 6, and this can't be 4 because of 4 in the row. So this is 1, which eliminates 1 here, so that's 4. Remaining digit in column 5 is a 6. Remaining digits in these digits, 2 is consecutive with this digit, and it cannot be 1, so this is 3. 5 is consecutive with this digit, and it cannot be 4, so this is 6, which makes this 3. This 3 eliminates 3 here, so it's 2 and 3, which eliminates 3 here, so it's 2 and 3, which eliminates 3 here, so that's 2. So we should have all the 2s, and we should have all the... well, we don't have all the 3s. The last 3 is over here. This 4 eliminates... that's 3 in the corner. We celebrate because we know we're close to solving it. This 4 eliminates 4 here. So this must be 1, which makes this 4. The last digit in row 6 is a 4, which means the last digit in column 6 is a 6, which means the last digit in row 2 is a 1. The last digit in column 3 is a 6. Herzliche Gratulation. Puzzle aus der Mindbenders Impulswoche NKSA 2025. Yeah, this was very cool. This is probably the easiest chaos construction I've seen. I always find chaos construction rules really fun, and I hope you did too, because, yeah, we kind of needed this, but we didn't really use it that much. But anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.